Good day, class. Welcome to this lecture series on lipids. In our previous lecture, we looked at the chemistry and structure of fatty acids. In this lecture, we'll be looking at the chemistry and structure of triacylglycerol. So, in our previous lecture, we defined lipids as substances that are insoluble in polar solvent or soluble in non-polar solvents. So, when we look at the chemistry and structure of triacylglycerol, we look at what makes up the triacylglycerol. A significant number of fatty acids in plants and animals exist in this form of triacylglycerol, also known as the triglycerides. Triacylglycerol are the major energy reserve and principal neutral derivatives of cholesterol found in animals. Now, when we look at triacylglycerol, we look at monoacylglycerol, diacylglycerol, and triacylglycerol. Now, in triacylglycerol, the backbone of triacylglycerol is the glycerol molecule, which is usually known as the proper 1,2,3-triol. Now, upon hydrolysis, if we are using the iron alkali, maybe something like potassium hydroxide, to hydrolyze the triacylglycerol, that process is actually known as saponification, and it's actually how ancestors made their soaps. So this is the structure of triacylglycerol. You can see the glycerol backbone here. Excuse me. Okay, you can see the glycerol backbone. You can see the glycerol backbone. So when the fatty acid is esterified to the first hydroxyl group without a fatty acid esterified to this or this, that molecule is termed monoacylglycerol. So both we have two fatty acids esterified at carbon 1 and carbon 2, or carbon 1 and carbon 3, we have a diacylglycerol. But when we have a fatty acid esterified to the 3-hydroxyl group, we have a triacylglycerol. So sometimes the fatty acid in the 3-hydroxyl group can be the same fatty acid, for example, as what we see in tristerine. Here we have the steric acid in the esterified to the 3-hydroxyl group. So this is an ester bond. I want to talk about esterification. This is an ester bond. And for such bonds to be created, water must be released. So here we have the tristerine, which is a simple triacylglycerol. Here we have a mixed triacylglycerol, which in the first one we have the myristic acid, which is carbon 14. We have the steric acid, which is carbon 18, and we have the palmitoleic acid, which is carbon 18, with a double bond between 9 and 10. As you can see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the double bond is between 9 and 10. Between 9 and 10. So this is a mixed triacylglycerol. So this is the structure of triacylglycerol, and this is the form in which energy is conserved or reserved in the biological system. So this is a polar bear with a sea bubbler. So the polar bear actually feeds on sea bubbler. Don't mind my arrow. The polar bear actually feeds on sea bubbler. Actually feeds on sea bubbler. So you can see that the sea bubbler is made up of, this is saturated fatty acid. More of their fatty acid is in the monounsaturated fatty acid. Then they have little, or if we compare to the saturated, we have the polyunsaturated fatty acid. So during the winter time, the polar bear feeds more on the sea bubbler to have enough energy to sustain them during the summertime. So during the summertime, the polar bear have normal activity, roaming around without expanding much of their energy, and they usually do not urinate or maybe take in water because of the oxidation of the fatty acid actually liberates water and carbon dioxide. So this is why we actually refer. This is why actually we actually refer the triacylglycerol as the energy reserve. So when you have more of the triacylglycerol in the biological system, we can talk about a long-term energy reserve than carbohydrates. Thank you very much. Do not forget to subscribe to my channel.